So, if you can't make the bases match, take the log of both sides. This will almost always be common log or natural log. Just because those are the ones that, if you have to do a decimal approximation, those are the ones that your calculator can do. The thing you have to understand, and this is vitally important, is that to kill an exponential, you use a logarithm. So let's say I had 4 to the x equals 15. We'll start simple. I can't make 15 match 4 as the base. That's just not going to happen. So what you have to do is you have to take the log of both sides. It was Mr. Walsh with the log in the classroom. That was totally a clue reference. You know, it was Colonel Mustard in the conservatory with a lead pipe or something like that. Anyway. So, it doesn't really matter what one I use. So, I take the log of both sides. Now, why would that be advantageous? Think about our properties. Where's x right now? Up in the exponent. Don't we have a property of logarithms that deals with exponents? And how does that work? Like if you recall, when we had the ln of x squared, how did we expand that? We did that the other day. Right. So you bring the exponent down. Well, the advantage to that is I'm getting the variable out of the exponent and I'm getting it into place, so to speak. So I bring this down, and it's x times the log of 4 equals the log of 15. So how do you get x? Not quite. Not subtract. This is times, isn't it? Yeah, divide. So if I divide both sides by the log of 4, because the log of 4 is just a number. It'd be no different if that said x times 2 and you divide it by 2. So x equals the log of 15 divided by the log of 4.
Do you want to still leave it that way, or do you want to actually?
Well, there are going to be some on the assignment, I think, where it wants you to approximate. And then there are going to be others where it wants an exact answer. If it wants an exact answer, you need to leave it like this. And if you know by now that if you read the little blue part and pay close attention to that, it'll tell you what it wants. Okay, so just, I would say that if there's ever any doubt, ask and I'll tell you what I want. Like, if this is on the test, more than likely this is what I'm going to want to see. And if I don't, I'm going to say approximate to X number of decimal places. Okay, now, if it's a real world application problem, like if we're trying to figure out how much money an investment is worth after, you know, however long, then you're probably going to want to do dollars and cents. So, but if there's ever any doubt, just ask. Try not to die. All right. So, I mentioned before that usually doesn't matter which log you use. On this one, it's going to be important to use the correct one. Would I rather use common log or natural log here? Why? The base of the natural log is E, right? What's the base of the common log? Like, what's the base of this logarithm right here when I don't write the base? 10. There's a 10 over there. That means you should use log base 10. So if I take the log of 10 to the x equals the log of 120,000. Guys, this is log base 10 and 10 to the power. What happens when you do that? They cancel. And look what you got. You got x. So if you can get the base to match, that works out really well. But if it's not 10 or E, then you just make it work. So what do you think about this one? That would probably be a good idea, because if you get rid of this 3, then you're trying to get your exponential by itself. And once you get the exponential by itself, you can kill it off with the logarithm. So I can add 3 to both sides. Then what? You should. Now what? Yeah, you would need to take the log at this point. You got to kill the exponential. You use a log to kill an exponential. So which log should I use? Natural log, because this is e, right? A natural log is base e. So I take the ln of this, I take the ln of that, and ln and e to the power cancel, because they have the same base. So how do I finish? Yeah. This one's tougher. You can't make the bases match. I mean, you could, but it'd be uglier than what's worth it. So what's our only other option? How can I get those variables out of the exponent? What have we been doing this whole little section? Yeah, you take the log of both sides. Now, it's not 10, and it's not e, so it really doesn't matter which log you take. So just for demonstration purposes, I'm going to use ln. Now the next step is very crucial. That was a combination between crucial and critical. Turned into critical. Easy there, Chief. All right, so if those don't directly cancel, there's another huge reason why you take the log of both sides. And if you recall, it's the exact same thing we did right here to get from this step to this step. How did that work? Yeah, you bring the exponent to the front. Now notice I'm going to have to use some parentheses here. So, all I did was take these exponents and bring them down to the front. Like I said, that's a critical skill. You got to know that that's the next step to take. Now what? Not quite, because I've still got an X over on the other side. Let's distribute. And we'll do that in the next video.